or flattening the weld on heavier metal. It is important to be consistent though. Varying the arc gap during the weld changes the heat, making it difficult to maintain a uniform weld puddle. When you start looking at all the aspects of running a weld bead, there are many possibilities. That's why everybody welds a little different. Practice and experiment, trying to make that puddle do what you want it to do. Watch other welders if you get the chance, but in the end, you need to see the weld puddle at the end of your rod and develop a style that works for you. We've been looking at heating the metal to allow the molten pool to penetrate and fuse. All that heat also has an effect on the base metal itself. Metal is made up of groups of atoms bonding together to form grains. When metal is heated past a certain temperature and cooled quickly, smaller grains are formed, making the metal harder. Cooling the metal slowly allows more atoms to bond, forming larger grains, which makes the metal softer. In welding, the metal adjacent to the weld bead becomes hot enough to change the structure of the grains. Because only a relatively small area is heated, the metal cools quickly, forming smaller grains and becoming harder right alongside the weld. Welding also causes the pieces of metal in the joint to draw. Heated metal expands, so during the weld, the molten filler metal is deposited in its maximum expanded state. As it cools, it contracts. When the metal is free to move, it will draw in the direction of the weld. If the pieces being welded are trapped, the molten weld metal still contracts, leaving some residual stress in the metal. There isn't any way to stop this. The metal is going to move. Whenever possible, weld on both sides to reduce the draw. And on pipe or square tubing, use a sequence of welds to help control the draw. Extreme differences in temperature do have a greater effect on the metal. If it's freezing cold, use a torch to heat the metal up a little. Condensation will appear, and just warm it up until the moisture dries. Also, if you are welding on harder, higher carbon steel, which does not handle expansion and contraction very well, a preheat may be necessary to prevent the weld from cracking as it cools. As always, there are a lot of variables, the type of steel and the stress that will be put on the finished product. In most cases, projects are designed so that the stress put on the weld joint does not come anywhere close to the maximum strength of either the metal or the weld. Try to complete the weld once you start it and avoid building up more weld than necessary. When you're finished, let the metal cool slowly. If the metal does break next to the weld, you may need to take a closer look at the thickness of the metal being used and the overall design. Okay, let's take a look at putting two pieces of metal together. The first steps with any type of weld joint are metal preparation and joint fit up. If you're working with new metal, most of the rods can handle the mill scale, which is a dark layer on the surface. Use a grinder to clean any metal that's rusted or painted. Impurities on the surface can cause porosity, lack of fusion, or even interfere with the arc. When you're cutting metal, keep the edges straight and square. If you use a torch, chip or grind off any slag left from the cutting process. During fit-up, use good tacks to hold the pieces together, and if you're leaving a gap, keep it uniform. Irregular gaps in the joint not only take longer to weld, they make it way more difficult than it should be. You can avoid a lot of problems by cleaning the metal and taking your time on fit-up. While there are many variations of weld joints, there is generally considered to be 4 types: butt joints, lap joints, T-joints, and corner joints. On a butt joint, the weld should penetrate deep, with the amount of weld deposit at least equal to the thickness of the metal. For maximum strength, 100% penetration welds are used to completely fuse the edges. On a lap joint, the weld is called a fillet, with the legs coming up and out a distance equal to the thickness of the metal, and the weld slightly crowned. A fillet is also used on T-joints, where the edge of one piece is joined to the surface of another. Welding on both sides reduces the amount of weld necessary and overall produces a stronger joint. Corners are joining the edges at an angle, with metal preparation or fit-up allowing for sufficient penetration and weld deposit. Let's start with butt joints, and this can be on plate, flat bar, angle iron, pipe, or square tubing. When the metal is around 1/8 of an inch thick, keep the edges straight and square for a perfect fit. You'll generally get good enough penetration just butting the pieces together, especially if you can weld on both sides or all the way around. On plate or flat bar, tack right on the outside edges to help carry the heat. For square tubing, tack the corners, then weld opposite sides from tack to tack. If you intend to grind the weld off for a smooth finish, you can leave a very slight gap, but keep it uniform. Whenever possible, start at the outside edge and weld towards more metal. In the flat position, hold the rod fairly perpendicular to the metal. You can weld with 60-10 or 60-11 using a circular motion. Turn the amperage down a little, but you're going to have to travel faster to control penetration and avoid burning through. For a smoother finished bead, try 60-13 or a 3/32 70-18 with a side-to-side movement. On a horizontal, hold the rod nearly perpendicular to the weld. Watch the puddle. With 60-10 or 60-11, adjust the travel speed to let the puddle spread out without overheating the metal. Watch the top side to avoid undercutting. With 60-13 or 70-18, try running straight without any rod movement, maintaining a uniform arc gap and travel speed. If you can position the joint, butt welds on 1/8 metal are easier welded vertical down. 1/8 metal is fairly thin for stick rod, so use some practice metal to figure out the amperage and adjust your travel speed. Starting at 3/16 of an inch, you want to bevel the edges to allow for good penetration. Bevels are generally around a 30-degree angle with the top edge straight and a flat spot called the landing on the bottom. Hold the grinder at a slight angle, using the bottom corner of the disc to take off metal. When you have it close, hold the grinder flat to smooth the bevel and straighten the top. On heavier metals, it may be easier to cut the bevel with a torch, then finish it with a grinder. The reason for beveling the edges is to control the puddle deep in the joint. If the bevel isn't wide enough to get the rod into the bottom, you can always take the grinder up on edge, slightly cock, and use the curve of the disc to open the bevel up a little more. A beveled butt weld can be divided into 3 parts. The root, which is the first pass fusing the bottom of the joint, the filler, and the cap. There are several options in fitting up butt joints, and the main difference is how the root pass is welded. The bevel pieces can be fit up with a small gap, allowing the first pass to penetrate as deep as possible. For 100% penetration, either a backup bar is used, with the first pass fusing all 3 pieces, or the metal is fit up with a gap, and the root fuses the bottom edge and actually builds weld on the back side. After the first pass, filling and capping is basically the same, so let's take a closer look at getting the joint started. Anytime you weld in a bevel, you want to hold the rod fairly perpendicular to the metal to flatten the top of the bead. If you angle the rod, the weld bead will crown, leaving slag that may get covered on the next pass. You also want the weld buildup even. Use a grinder to knock down any high spots from stopping and starting. It's a lot easier to keep it uniform with a grinder than to try to fix it with the next weld bead. Also, if the bead does crown in the bevel, use your grinder to knock off the top to avoid trapping slag. Not all welding situations require 100% penetration. That depends on the type of stress placed on the joint, but you